What is the history behind Euclid's parallel postulate debate? Imagine trying to build a perfect map of the universe using only simple rules. One of those rules in geometry is about lines that never meet. That's what we call parallel lines. Now, a long time ago, a famous mathematician named Euclid wrote down 5 basic rules for geometry. The 5th rule, called the parallel postulate, was the most complicated and least obvious. It said that if a straight line crosses to other lines and makes the inside angles on the same side add up to less than to right angles, then those 2 lines, if extended forever, will meet on that side. But many mathematicians wondered if this rule was really necessary or if it could be proved from the other 4 rules. They thought maybe it was just an obvious truth, like the first 4 rules, which are simple and easy to understand. For over 2,000 years, mathematicians tried to prove the parallel postulate using only the first 4 rules. They worked hard, but every attempt failed. Some tried to replace the postulate with simpler statements, like Playfair's axiom, which says that given a line and a point not on it, there is exactly one line through that point parallel to the original line. This version was easier to understand and is logically equivalent to Euclid's original rule. Then, in the 1800s, everything changed. Mathematicians like Carl Friedrich Gauss, Nikolai Lobachevsky, and János Bolyai started exploring what would happen if they changed the parallel postulate. They discovered that if you replace it with a different rule, you get a whole new kind of geometry called non-Euclidean geometry. In hyperbolic geometry, for example, through a point outside a line, there are infinitely many lines that do not meet the original line. This was a huge breakthrough because it showed that the parallel postulate is not a must-have rule. Instead, it is a choice that leads to different types of geometry. This history is important because it helps us understand why parallel lines behave the way they do in the geometry we learn in school. In Euclidean geometry, the sum of angles in a triangle is always exactly 180 degrees, and parallel lines never meet. But in non-Euclidean geometries, these rules can change. The debate over the parallel postulate shows us how a single assumption can lead to many different ways of understanding the world. It also reveals how mathematicians have worked for centuries to question and expand the rules that shape our understanding of space and shapes.